Hey everyone, welcome to The Explainer. Today, we're jumping right into what I like to call the cosmic dance: fire, rock, and gravity. When we look up, the sun and the moon look like they're roughly the same size, right? Kind of taking turns dominating the sky. But are these incredibly familiar objects actually playing tricks on our eyes? Well, spoiler alert, yes, absolutely. The reality out there in the cold vacuum of space is way more dramatic and, honestly, infinitely more fascinating. Let's kick things off at the absolute center of our solar system. We're talking about a massive anchor that literally pulls everything toward it and, makes life possible. Because of its sheer, mind-boggling size, the sun has this incredibly strong gravitational pull. Think of it as an invisible tether that keeps Earth, the other planets, and the moons perfectly in line. Without this central anchor, we just go spinning off into the freezing, dark depths of space. Not a great thought, right? So, the main takeaway here is that the sun isn't just some bright light bulb in the sky. It's a colossal 4.5 billion-year-old star, and it's made entirely of burning gas. It started out as this giant cloud of dust and gas way back when, and today it's basically just hydrogen and helium. It dictates our seasons, grows our food, even tells us when to sleep. It is the ultimate battery powering the whole shebang. 10,000. That is the staggering temperature in degrees Fahrenheit of the sun's surface. And get this, the inner core is actually way hotter. I mean, just imagine the sheer heat it takes to send light all the way to Earth, a trip that takes 8 minutes at the speed of light, and you can still feel it warming your skin. But here's the wild part. The sun isn't technically on fire like a campfire in your backyard. Actually, it generates that intense heat at its core through thermonuclear fusion. It's literally smashing atoms together. And this creates a continuous churning cycle. The superheated gas in the deep center rises all the way up to the surface. Once it's there, it cools down just a bit and falls right back down into the center to start the whole process over again. It is essentially a giant, cosmic, boiling pot. All right, let's zoom out from that massive, blazing star and look right into Earth's immediate orbit. We're going from the chaotic, raging heat of the solar system's core straight to our quiet, closest neighbor, our only natural satellite, the moon. And wow, the contrast couldn't be sharper. We go from a giant sphere of burning gas to a small, dusty ball of rock. To put that into perspective, the moon is roughly a quarter of the size of the Earth. It has no blazing fusion core, no massive gravitational dominance. It is quite literally just a quiet, dusty ball hanging out in space. And because the moon's atmosphere is incredibly thin, it doesn't have a protective blanket like Earth does to burn up meteors. So it's been battered, heavily battered by impacts for billions of years. This leaves a really harsh, scarred landscape defined by huge craters and these big, flat seas of hardened lava. Now, going back to that thin atmosphere, it means the moon can't trap or distribute heat. Because of that, its temperatures swing violently from scorching hot to freezing cold, all depending on where the sun's light hits. When the sun is blasting the surface directly, temperatures skyrocket to 127 degrees Celsius. But as soon as the sun goes down, that temperature instantly plummets to around negative 153 degrees Celsius. Talk about extremes. 1/6. That fraction right there represents the moon's gravity compared to Earth's, which means if you were standing there, you'd weigh significantly less. Now, the moon does have gravity. That's what keeps the dust and rocks held together. But because its mass is so much smaller than Earth's, that invisible pulling force is way weaker. You'd feel incredibly light, basically able to bounce across those flat lava seas like you were on a cosmic trampoline. So this brings us to a beautiful cosmic illusion that we get to witness every single month. We've all looked up and seen a full circle, right? Or a half moon, or just a tiny crescent sliver. It honestly feels like the moon is physically growing and shrinking up there. But of course, we know that rocky ball isn't actually changing its shape. So what exactly is happening? Well, probably the biggest misconception out there is that the moon glows. But the truth? It's just a giant rocky mirror reflecting the sun's immense light. The moon doesn't produce a single photon of its own visible light. So that brilliant silvery glow that lights up our night sky, it's entirely borrowed from our blazing star, bouncing off the lunar dust right back to our eyes. As the moon takes its 27.3-day journey completely around the Earth, the sun illuminates different parts of its surface. Picture it like this. The sun is a massive, fixed spotlight in the center. And as the moon slowly circles around us,
the angle of that spotlight hits the moon differently from our earthly perspective. Ultimately, those changing shapes, the phases of the moon, are purely a trick of perspective based on our angle to the sun. The moon itself is always a complete, solid sphere of rock. When we see a half moon, we're really just looking at the moon from an angle where exactly half of the side facing us is lit by the sun and the other half is cast in its own deep, dark shadow. Now, what's really interesting here is that because of the way it orbits, we only ever see about 60% of the moon's surface from Earth. We call that the near side. See, the moon rotates on its axis at the exact same rate it orbits the Earth. They're perfectly locked in this cosmic dance, meaning the exact same face of the moon is always pointed toward us. That remaining 40%, that's the mysterious far side that we literally never see from our backyards. And get this, if you were standing on that near side, you'd experience a single day that lasts for over 13 Earth days before the long night finally sets in. Just imagine the sun rising and taking almost 2 full weeks to cross the sky, baking the surface to 127 degrees Celsius, and then almost 2 weeks of absolute freezing darkness. It is an environment of pure extremes. Okay, let's tie all of this together. The sun anchors everything with its immense gravity and energy, while the moon faithfully orbits us, reflecting that energy back down to Earth. The sun constantly pulls us in, but the Earth's movement pulls against that force. Because of this perfect push-pull effect, we don't crash into the sun and we don't float away. We stay right in the sweet spot, with our moon keeping us company in the dark. As this quote perfectly highlights, the stakes here couldn't be higher. This delicate, interconnected push and pull relationship is literally the absolute foundation of our existence. That 4.5 billion-year-old sphere of fusing hydrogen and helium, it is the absolutely crucial thing standing between our beautiful, vibrant planet and the icy, dead vacuum of deep space. So think about that cosmic balancing act tonight when you see the moon reflecting the fire of a star millions of miles away. It's not just a rocky sky lantern. It's a mirror showing us the sheer power of the sun and a beautiful reminder of the magnificent clockwork precision of the universe that allows us to even be here asking these questions. Thanks so much for joining me on this explainer. And hey, keep looking up.